Hi everyone, my name is Thomas Kim. Today is November 1st, 2019. This is my 10th episode about linear algebra and threading building blocks. In this episode, we will learn how to evaluate determinant of a matrix using Leibniz Formula. For more information about determinant, please double-click this link. If you scroll down, you can find this formula. This is called Leibniz Formula. Also, double-clicking this link, you can learn more about Leibniz formula for determinants. Please understand that this method is very inefficient, so you should not use this algorithm. However, I will guide you how to implement this algorithm. Directly evaluating Leibniz formula from the definition requires omega n factorial times n time complexity. It means it's very inefficient. More efficient algorithm is LU decomposition. It is big O n cubed time complexity. The reason I'm introducing this algorithm in this episode is next permutation. Please double-click this link. Next permutation, we will be using this function in this episode. Also, I will use std generate n algorithm. Please double-click it. We will be using this algorithm. Also, if you haven't watched my previous episode, please double-click this link, and from this video, show more, download the source code. Please double-click this link because we will need source code of our previous episode. Also, I updated C++ library extension. Please double-click this link. Even if you installed this library before, please double-click this link and download again because I updated this library today. Show in folder. Please unzip this CPP extension library. Then copy this folder, copy, and paste it to your working folder. In this folder, please remove your previous installation, delete, then paste updated library. Also from download folder again, unzip our previous source code, right-click, rename 10 Leibniz Determinant. Change the folder name, copy, and paste it to your working folder. This is my working folder. Now start Visual Studio Code. You should have this folder. Double-click matrix.cpp, the source code we developed in our previous episode. From this file, we will remove all up to this point, and we will also remove the contents of function main, like this. And right-click, copy, click the folder, paste, right-click, rename, template.cpp. We will be using this file in some future episodes. Now close it. Open linear algebra.hpp here. Include talk play fun set.hpp. Now in matrix, go to file, save all. Void test Leibniz determinant. I created a simple function, copy, and paste it in the function main. Now here, matrix, we can use any two-dimensional matrix. I will use aligned shape matrix, double M. It will be 3 by 3 matrix or size Tn 3. Then I will modify it n by n matrix. 3 by 3 matrix. We need a sample code, so please double-click this link. Scroll down. We will use this matrix. I will arrange it M00, 0, 0 element is minus 2, this number, minus 2, M01, 2, M02, minus 3. Now copy, paste, paste. It should be 1, 1, 1, and it should be 2, 2, 2. This value is this number, minus 1, and the next number, this number is 1 and 3. Now this number is 2, and this number 0, and this number minus 1. Now we will print out the contents of our matrix. Stream M equal M, and there. I will modify like this. Now in the command prompt, dir cd 10 Leibniz Determinant. We are compiling this matrix.cpp using Clang++, std C++17 matrix.cpp TBB malloc, hit enter, cls a. So this is our matrix. Minus 2, minus 2, 2, minus 1, minus 1, 1, 3, minus 1, 1, 3, 2, 0, minus 1, 2, 0, minus 1. We will create an index vector std vector size t index std generate n std back inserter index n is the element count of this matrix. I declare count equal 0. It should be mutable, then blocks. Now here we will return count plus plus. It should be generate n. Stream index index and there. Now we build once again using Clang compiler. So this is index. If we use GNU compiler, we can simply change like this. GNU compiler also works. If you are using Microsoft compiler, dir cd 10 Leibniz Determinant cl ehsc std C++17 matrix.cpp TBB malloc .lib fe m.exe, hit enter, then m. This is Microsoft compiler. Now again here, I create a do while block. Now here we use std next permutation index begin index end. Now in this block, stream index. Now we will use Microsoft compiler again, m. So permutation of this index vector is created like this. For more information about std next permutation, please double click this link and refer to this c++reference.com website. I will put stream permutations and there. Also, please note that I created Talk Play Fun, NCR, NPR, SGN, index, and there I am using GNU compiler. We build again using GNU compiler A. In this matrix, this number plus 1, minus 1, plus 1, these are SGN. SGN is this symbol. Okay? For more information about this SGN sign, please refer to this document, Leibniz Formula for Determinant. You can see where the sign is in this formula. This SGN is this sign function of permutation. Okay, if you double click it, you can read more information about this function. If you want to know how I implemented this function, then right click, go to definition, then talk play fun ncr_ampere.hpp. This sign function is defined like this. This algorithm is pretty simple. About this algorithm, Schaum's outline of linear algebra, 5th edition, at page 267, sign over permutation. In this book, you can find the algorithm of this sign function. I think implementation of this algorithm is pretty simple. I will not explain about this function. Let's keep going. I will close this file, also this file. Now in this block, I will delete it. Auto term 1.0 for auto I equals m start index. This is actually 0. I less than n rows plus I terms times m I index I. I will explain this part shortly, so please bear with me. Out of the for block, here I will define auto det 0 if talk play fun ncr npr sgn index is greater than 0. It means even permutation. Then det plus term, else det minus equal term. Then after the loop string, determinant det and there. Now we will build with the GNU compiler CLS. The determinant is 18. Okay, the determinant is 18. Using with Microsoft compiler, Microsoft compiler also works. You probably wonder how it works. So I will explain. I will copy this part, copy, and paste it here. I will simply remove this part. Instead, stream, index, SGN index, talk play fun, NCR MPR, SGN index, and there. I put this message, and here stream det, and here I will copy this part, and I will paste it here, stream plus stream minus, and in this block stream m I index I will copy this once again, pasted it here. If I plus 1 less than m rows, then times else and there. Now let's build once again. We will use Clang compiler CLS. So determinant is computed m00, m11, m12 minus m00, m12, m21. Please note that row index changes 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. Then the column index, this column index is permutation. I will make it smaller. Please watch this column index. 0, 1, 2, 0, 2, 1, 1, 0, 2. This is permutation. This permutation 0, 1, 2, 0, 2, 1, 0, 1, 2, 0, 2, 1. Okay. The column index is this permutation 2, 1, 2, 0, 1, 0, 2, 1, 2, 0, 1, 0. Okay. We are basically applying this rule. Okay. This is the rule. Also, this is term. This phi ai times sigma I, this term is term. And it is summation. We did summation. Or if you double click Leibniz formula, we are applying this formula. SGN determines plus or minus. Okay. This term, product, this is product. This algorithm, Leibniz determinant, is very inefficient. Let's analyze time complexity. In two blocks, this is permutation. So if n is m log counts, this do loop computes n factorial. So n factorial terms are calculated, and each term has n times multiplication. So multiplication alone, the time complexity is n. This is just for multiplication. Directly evaluating Leibniz formula from the definition requires omega n factorial times n factorial times n permutation, and n multiplication for each term. This is for multiplication only. What about this permutation? Generating permutation is also very time consuming. Also, determining the sign of each term, it is also time consuming. So this algorithm is very inefficient. Also, this is serial computation. Next n permutation is an algorithm based on serial programming. In our future episode, we will turn Leibniz determinant algorithm or formula to parallel algorithm. I will upload complete source code to my website. By the time you watch this video, you can double click this link and download complete source code of this episode. Please subscribe to my YouTube channel. Thank you for watching.